In this example, we'd like to find dy dx if 1 over x plus 1 over y is equal to e to the 2y. We will use implicit differentiation, and we will assume that y is a function of x. And to help us here, let's recall the derivative of 1 over x is negative 1 over x squared. That comes from the power rule, because 1 over x is x to the negative 1, and negative 1 over x squared is negative x to the negative 2. If you take the derivative of x to the negative 1 using the power rule, you should end up with negative x to the negative 2. So the derivative of 1 over x is negative 1 over x squared. Okay, so in this problem, to find dy dx, we will take the derivative of both sides of the given equation with respect to x. So d over dx of 1 over x plus 1 over y equals d over dx of e to the 2y. So now calculating these derivatives, as mentioned a moment ago, the derivative of 1 over x is negative 1 over x squared. And now plus the derivative of 1 over y, this one requires the chain rule because y is a function of x. The letters don't match here. We're doing derivative with respect to x of 1 over y. We have to treat that as a composition where y is inside of the reciprocal function. So use the chain rule. The outside function is the reciprocal function. The derivative is negative 1 over y squared. And then times dy dx, chain rule, equals the derivative of e to the 2y. This is also chain rule. The inside function is 2y is inside, and the outside function is the exponential. So the derivative of the exponential is itself, so that's e to the 2y, times the derivative of the inside. The derivative of 2y is 2 times the derivative of y, so 2 times dy dx. So now we have to solve for the symbol dy dx. So I have negative 1 over x squared is equal to 2e to the 2y times dy dx plus 1 over y squared times dy dx. So negative 1 over x squared is equal to dy dx times 2e to the 2y plus 1 over y squared, which means that dy dx is equal to negative 1 over x squared over all of this, 2e to the 2y plus 1 over y squared. And the nicest way we can make this look is to multiply the top and the bottom both by x squared times y squared, and we will get dy dx equals negative y squared over 2x squared y squared plus x squared. That's about as nice. I missed something there, excuse me. It's negative y squared on the top, and on the bottom it's 2x squared y squared times e to the 2y, missed that last time, plus x squared. So if you take this fraction and you multiply the top by x squared y squared, the x squared will cancel and you'll be left with the y squared. And if you multiply the denominator by x squared y squared, then it will pop up here, as we see right there. And if we multiply this one by x squared y squared, the y squareds cancel and you're left with just x squared. Okay, so the answer is negative y squared over 2x squared y squared e to the 2y plus x squared.